Right then, welcome back. In this lecture, we are going to be starting exercise 13E and we are going to be doing the difficult questions from it. Remember that we are doing D3 from New Syllabus Mathematics, 6th edition for O-levels. Here we are. We are given 3 points X, Y and Z that can be placed randomly on a circle, but we are constrained that Y, X and Z angle is 43 degrees. Now we're told that the tangents at Y and Z meet at W as we have shown on the diagram. You have to find the angle YWZ that is shown in red. So let's start with the solution. Let's join the center of the circle O with Z and Y. From this we can gauge some valuable information. First of all, YOZ is twice of YXZ. This is because the angle subtended at the center is twice that angle subtended at the circumference of the circle. You can see that Y and Z are common to both angles. We can also see that OYW is equal to OZW. Why? Because a line from the center of the circle which touches the tangent at the circumference will have an angle of 90 degrees with the tangent. Now consider the quadrilateral OYWZ. In a quadrilateral, the sum of all the angles inside of it is 360. Now we know 3 of the angles and we can easily find the 4th. And this comes out to be 94 degrees and that is our answer. Now let's move on to question number 7. Here we are. In this diagram, AB is a tangent to the circle and its center is O and D is the midpoint of the chord BC. Now BAC is given as X. You have to find COD marked as red in terms of X. We start off by noting BOA angle equals 90 minus X because sum of angles in a triangle equals 180. Similarly, angle COB can be calculated as 180 minus 90 minus X. Why? Because points A, O and C lie on the same straight line and sum of angles on a straight line is 180. Now we notice that OB equals OC because both of them are radii, and noting that the triangle OBC is isosceles, we can find angle OBD which is equal to the angle OCD, and so together they get the value 45 minus X by 2. Now CDO is also 90 degrees and we now turn our attention to the smaller triangle COD. Sum all the angles and equate them to 180. This gives us the answer. Angle COD equals 45 plus X by 2, and as required we have expressed COD in terms of X. Now the last question we are going to do from this exercise, which is difficult, is question number 9. Question number 8 is just like question number 6, and if you have understood question number 6 you can easily do 8, but 9 we are going to tackle. Now in question number 9, PA is the diameter, PT is a tangent, and S is a point on the circle such that SPT as shown is 46 degrees. In the first part of the question you are supposed to find PAS, which is marked in red. Now firstly notice that OPT is 90 degrees because OP is the radius and it forms 90 degrees with the tangent. This would mean angle OPS is 90 minus 46, which is 44. Draw a line from O to S. Now notice that angle AOS, which is marked on your screen, is twice the angle OPS. Why? Because the angle subtended at the center is twice the angle subtended at the circumference. And you can see that the points A and S are common to the portion that is subtended by each angle. Now we notice that OA equals OS because they are the radii, and so the angle OAS would equal the angle OSA. We can now easily find the value of OAS by considering the triangle SOA, and this comes out to be 46 degrees. Now in the next part of the question, we are asked to place R on the minor arc PS, and we've done so, and find the angle PRS. However, now consider the quadrilateral PRSA. You notice that PRS is an opposite segment to PAS. Yes? And so, we know that their sum is going to be equal to 180, and we can easily find PRS 4 degrees, and that is our answer. So this is it for this lecture. Next up, we are going to be doing the review exercise of chapter 13, and we are going to be doing the difficult questions only from this one. The link for the next video is in the description. After this video finishes, please click on it and we can start with the next lecture. Thank you for watching.